My name is Frank Schmidt. I'm commercial manager for Volvo Construction Equipment here in Germany, so I'm responsible for the sales in Germany. First use of batteries, as you said, obviously in a vehicle. Then the battery is new, and then we permanently monitor and check the battery, and then usually at the stage of 80 SOH, state of health, which is depending on many parameters, we give the battery a second life. So we not destroy and recycle the battery at that point of time. We usually use the battery for a second application. And that could be, for example, in one of our power units, where not a full capacity is needed, because you just store the energy for an intermediate period. Or maybe you use it in a housing. For example, you have the solar panels on your roof and want to store the energy for the evening when the sun is not shining, or for the night. At the far end of the battery will be recycled, all the minerals will be recovered and then used in new batteries again. So there's a very expensive and useful material in the battery, so you never destroy and throw it away. But first of all, you need to understand how a thermal runaway occurs. There are certain situations where it could happen. One could be a contamination of the battery during the production process. There could be other things which are internally in the battery when it comes to short circuits, or from external with damages, for example, like on an accident. But however, in our machines, and usually in all the batteries, you have a kind of battery management system, which is permanently monitoring the situation on the battery, checking the short circuits, checking the temperature. The charging and the discharging of the battery is also done in this optimal temperature range. If we are exceeding, for example, a range which is above 30 degrees, then the battery will be actively cool. Or we are below the necessary temperature, the battery will be heated up. So we have a really good management system in the battery which prevents this kind of thermal runaways. And then in addition, when you have an external damage of the battery package, usually the battery package has such good sealing and built-in which can withstand the internal pressure. So an external damage and a runaway is really unlikely. When we look on electric vehicles, we have much less moving parts on that vehicles. And less moving parts means automatically less wear on the machine. As said, the batteries will be changed at a state of 80 SOH. So as soon as you put a new battery in, you have no wear on the running and moving parts. Basically, you have nearly a new machines. So in my personal opinion, the resale value and the value of the machine itself will stay at a higher level than conventional diesel-driven machines. When we look at the moving parts, the biggest thing what we have removed out from these electric machines is the combustion engine. Alone the oil exchanges which we are needing to do usually on the diesel engines, it's gone away. So we do not have any maintenance and the labor cost on that part, but we also have no environmental impact as we don't have any disposals with aged oil, which we need to recycle. When we talk about electric machines, the obvious thing which comes immediately into our mind is the exhaust. So we do not have a diesel engine, means we do not have a kind of CO2 emissions or oxide emissions. But beside that, you have a lot of additional benefits like operator comfort, as you do not have any vibrations on the machine, but also you do not have any noise. That means very quiet environment for the operators, but not only for the operators, but also for the surrounding where the machine is working. So for example, you could do a night work in an urban area without disturbing the sleep from the neighbors. Yeah, when we started the journey with electrification of the machines, we thought we could electrify compact machines only, as they have a certain and lower energy demand than bigger machines. But in the meantime, the battery technology has improved and it goes further on. And as we show it here today, we have the first GPE machines electrified, our EC230 and as well as our L120 machine. So it will go on. And I think, it's my personal opinion, when it comes to hydrogen on the compact machines, we will not find it. Pretty simple reason for that is we do not have the space to put a fuel cell in that machine and the tanks for the hydrogen. And on the other side, basically you have two driveline concepts on the machine. One, an electric driveline, as well as the production of the electricity in the fuel cell. So that's, from a cost point of view, not efficient at all. I don't think so. Everything is depending on the battery capacity. As more battery packs you put into a machine, that means also you can raise up the size of the machine. But you need to find here the right balance between the battery capacity and the runtime, because you want to save resources. And we as Volvo, we have the idea that the machine should run a work shift, basically 8 hours a day with one intermediate charge during the lunch break. And that's what we achieved today with the EC230 and with the L120. Yeah, when we talk about the recharge, then and the time which we are mentioning in our brochures and the documentations, that's when we are charging the battery from 0 to 100. Or basically the battery best range there between 80 and 10% there. But however, when you reach the lunch break time, the battery will be not fully empty. So you're not charging from the bottom to the top here. You start at a certain level and then reach the top, and then you have enough capacity for the rest of the day.